Spoiler alert, there won't be any theory regarding the stunts made using motorcycles. This video will be based on stability of bike when you are taking a turn at high speed. Okay, so let's get right into it. Prerequisite to the video, you should know something about how gyroscopic couple works. I have explained that in the previous video, and you should know the equation for gyroscopic couple. Okay, that also is explained in the previous video. For people who are watching this for the first time, I'll show you a small clip on how gyroscopic couple works. The clip is from another video in YouTube from Walter Lewis, Professor Walter Lewis. You should also follow him if you want to know more about physics. He is really good at. He's a legendary teacher, if you want to say. Really good, shows how to. I learned more about it from his videos only. So I'll show you a small clip from his video about gyroscopic couple on how it works on practically. Okay.
I'm going to torque exactly as you see on the picture there. You ready? I stop the torque, nothing happens. I torque backwards, I keep torquing. I keep torquing, I feel it in my hand, I really have to push. I keep torquing, and I stop torquing and it stops. I'm going to torque exactly as you see.
See, that is how gyroscopic couple works. So there are two motions that is happening in that wheel. One is the rotation of the motion, and one is the in which he turns it to the side. And these two rotational motions that is perpendicular to each other causes a third motion which is perpendicular to these two forces, which turns the whole chair. Okay, so on to how the stability of the gyroscopic couple is. Okay, so this will be how the gyroscopic couple will be, in which three gyroscopic couple will act. Okay, so we are discussing when a bike is turning and how it is still stable even though it is not, how it is not falling down basically. So this is a bike turning towards the right side. The major two parameters are the radius of curvature of the curve and angle of heel with respect to the horizontal. So there will be many terms regarding this. Let's go to a simplified figure. Okay, this is the bike plus the rider's whole thing simplified into a figure. Okay, this is the angle, and this F will be the centrifugal force that is trying to overturn the bike, and this the force causes the centrifugal couple that is shown in the top, and here mg is the weight, where m is the total mass of the vehicle and the rider. Okay, and this theta will be this same thing only. Now this h is the height of the center of gravity of the combined weight from the ground with respect to the axis of the vehicle only, not horizontal axis, with respect to axis of the vehicle only. Okay, so we can resolve into two, h cos theta and h sin theta. So we can find that f into h cos theta will be the centrifugal couple, and this mg into h sin theta will be the couple due to its own weight. So we have two couples now. One is due to the weight, that is because of slanting, and one is due to the centrifugal couple. Okay, so there is one more couple, that is we all know, gyroscopic couple. Okay, so let's go on to it, how to find the gyroscopic couple. We are taking the gyroscopic couple. We know the equation for the gyroscopic couple as I into omega p. Here I am taking it as omega dash for clarity, not to confuse with the omega in the equation with the omega in the our situation. Okay, so we have a top view of the bike. This will be considered this the wheels from the top. Okay, so omega will be in this direction perpendicular to the rotation of the wheel, and omega p will be in this direction. See, we need to have that omega and omega p should be perpendicular to each other to directly match the equation. Omega dash is perpendicular to omega p, so we have to consider omega dash as omega cos theta, because omega cos theta is perpendicular to omega p, and therefore we will take omega dash as omega cos theta. Okay, so we have gyroscopic couple as I into omega dash into omega p, that is I into omega cos theta into omega p. Okay, so let's get into it. I is the total mass moment of inertia of the whole body. There are mainly two rotations. One is due to wheels, one is due to an engine. Both are taken into consideration. Due to wheels, there are two wheels, so we have 2 into I omega, which is the mass moment of inertia of the wheels, and then we have plus or minus G into IE, where G is the gear ratio and IE is the mass moment of inertia of the engine. And it is plus or minus because the engine rotation and wheel rotation might not be going hand in hand, and depending on it might be plus or minus. Okay, so that is how it is. And then we have omega, angular rotation of the wheels, and that will be direct easy equation, that is a linear velocity by radius of the wheels, that is v by r omega. Then omega p, we have linear velocity by angular precession is the angle due to the rotation through curvature, and that will be v by r, which is where v is the linear velocity of the vehicle and r is the radius of curvature. So we have v by r as the omega p. So gyroscopic couple, we can directly put all of this in the starting equation, that is I into omega dash into omega p. I is 2 into I omega, sorry, 2 into I w plus or minus g I e, and omega dash is omega cos theta, that is v by r w into cos theta, and omega p is v by r, and we put v by r and v all of this together, we have the final equation as v square by r into rw into 2iw plus or minus g ie into cos theta. Okay, so it has been rearranged and this is the final equation. Okay, we have coupled the couple due to weight mgh into sin theta. Then we go to centrifugal force will be mass into acceleration basically. So angular acceleration will be, this is will be the value of acceleration, m into v square by r, and then we have centrifugal couple, and I think we know how this I don't have to explain more about centrifugal force because that we have been learning from school, so I won't be discussing more about that. Then centrifugal couple will be force into this distance, so that will be h cos theta, f into h cos theta. F will be mv square by r, and h cos theta will be the distance, so we get mv square by r into h cos theta. So for stability, the overturning couple should be equal to the balancing couple. So here the overturning couples are the centrifugal couple and the gyroscopic couple, and the balancing couple will be the weight, couple due to weight. So we can directly put it together and we'll get this value, gyroscopic couple plus centrifugal couple equal to the balancing couple, that is the couple due to weight. So we directly put those equations together and we finally get the final result. This will be the total weight, how the couple final stability equation. So this will be how the couples will be distributed, the three couples, reactive gyroscopic couple, couple due to wheels, and couple due to recession. As you can see, those three are in three different planes perpendicular to each other. Okay, so this will be our next video on basically how the ships are sailing, how it is turning in the middle of the ocean and all. Okay, so look forward to the next video. Okay, follow me on Twitter to see how the videos are coming. Thank you all.